Okay, so we're going to continue talking about abstraction in Java. Last time we talked about abstract classes, and I want to talk about one more example of abstraction, and it's called interfaces. And this is one of these ideas in Java that, like, I understand interfaces, and I can program you an example right now that explains what an interface is. But I don't have, because I'm not a professional object-oriented programmer. I don't program apps. I program mathematical simulations to solve physics problems. I've never had a situation in my programming life where I'm like, oh, you know what the right solution for this problem I have right now would be? It would be making this an interface. So it's one of these things that, like, I understand in principle, but I've never really implemented in practice. So maybe I won't do a great job explaining why you would ever use interfaces. Um, but I'll do my best, and I'll point you to some other videos that might do a better job than me. This is our program from last time. It was showing how you can have an abstract class that you would never create an instance of. I would never, suppose I was writing a program to keep track of my pets, or I run a pet store and I have a database of all the, or a veterinarian database of all the animals that might come to the vet, right? I would never create an object in that database called an animal. An animal is too generic to be a useful thing to create an instance of. I could create cats and dogs and guinea pigs, and those would all be subclasses of animal. But the reason to make the animal class abstract rather than just a normal class is that you would never create an instance of that thing. It's just an organizing box to put all the animals in. And so we had this animal class. We had a cat subclass that extends animal, that you can actually create an instance of cat. We had a dog subclass that extends the animal class. I can actually create an instance of the dog, and every one of these subclasses has a make sound method just to have them do something. So when I run the program, I create an instance of a cat. I create an instance of a dog, and then I have the cat object run its make sound method and the dog object run its make sound method. So the cat says meow, the dog says woof woof. We talked about another reason to use polymorphism, to have these different animals have different methods, is so you could maybe have an animal that doesn't make a sound. So I created a turtle class, and its make sound method is just that turtle is quiet. It doesn't make a sound because turtles can't make a sound. This raises an interesting issue, which is you can imagine creating a class where maybe all the objects say they share similar instance variables, but some of them can do things that the others can't. And it makes sense for some of them to have methods that the other ones don't. Like, it makes sense for a dog and a cat to have a make sound method, but it doesn't even really make sense for the turtle subclass to even have a make sound method. And when you've got subclasses, everything has to have an implementation of those methods. Even if you don't create your own method to override it, you have to put it in that default method. It would be better if there was some way to have different objects of the same category implement different methods entirely. And that's sort of what an interface lets you do. And I'm going to try to create an example of that. We're going to take the turtle out for now. Let's just have our cat and our dog. And instead of an abstract class called animal, I am going to create an interface. An interface is a blueprint for the methods of a class or object. So all animal is a blueprint for the methods that animals can have. For example, make sound. Interfaces are by default abstract. So I don't even have to say that this make sound method is abstract. A method inside of an interface is implicitly public and it's implicitly abstract. It is just saying when I create an animal, it is going to have a make sound method. This isn't it. This is just a blueprint for anything which is an example of an animal. One of the things I think it confuses me the most about interfaces in Java is it doesn't seem like the right word to me. It doesn't, the word interface, like the way we use it in regular English, doesn't seem to me to describe what it does in Java, and I think that's one of the things that's most confusing about it to me. So, animal is no longer a kind of object. Animal is a collection of behaviors, is the way to think about an interface. Interfaces don't have instance variables. I could not create instance variables in this that are like age, name, number of feet, right? Interfaces are just blueprints for behaviors, for methods. So this says that anything I create called a animal is going to have a make sound method. And the word we use instead of extends is implements. Okay, so cat is an implementation of the methods. Well, that isn't even the right way to say that. See, this is what I mean about just the vocabulary. Methods of the animal interface. What I would say is the cat is able to implement the methods of the animal interface. So when I say that class cat implements animal, whatever an animal can do, a cat can do, is the way that what we're saying. So we've got public void make sound system dot print cat says meow. That's the end of my cat class. Okay, let's tighten this up a little bit so we have a little less white space. And we're going to do the same thing for dog. A dog is also able to implement the methods of the animal interface. So class dog implements animal. Make sound. Dog goes woof woof. Okay. So that's that. No, I don't think I have to change anything. I have to change this to subclass. They're not subclasses anymore. If I run this now, it should work, I think. There you go. What did I just accomplish? It seems like a step backwards because now dogs and cats are not even members of the same class anymore. This starts to make sense when you realize that you can have objects that you want to have some of the same behaviors, but not all of the same behaviors. Let's create another class. Another class that implements animal. Okay, let's make a snake. Okay, another class implementing the animal interface. Class snake implements animal. All right. Public void make sound. System print. The snake says hiss. Okay, snakes make a little bit of sound. Now let's make a snake. We will name him Sid. Okay, Sid was the name of the 13-foot python at the Science Museum where I used to work when I was in college. What did I just do? I just accidentally deleted the line I put in. Create a cat called Percy. Create a dog called Hazel. Create a snake called Sid. And then Percy makes sound. Hazel makes sound. Then we'll have Sid the snake make a sound. Run. Okay, so there's my execution of the different make sound methods of each of these classes. Cat, dog, and snake. Let's go back to this idea that I run a veterinarian / pet spa. And I want my record system to keep track of all the things that dogs and cats and snakes might do in my pet spa. There are some things that you might do with a dog and a cat that you wouldn't do with a snake. For example, if your cat or dog goes to the pet spa, they might get brushed and groomed. Cats can get brushed and groomed, and dogs can get brushed and groomed. But snakes can't really get brushed and groomed because they don't have fur. So if I want a method that's get groomed or get brushed, it should only apply to cats and dogs, but not to snakes or turtles or frogs. So I wouldn't make that part of the animal interface. I could create a new interface that contains only the methods that are applicable to animals that have fur. I will call that interface has fur. And I will call the method that belongs to that interface get brushed. And right now, get brushed just prints your pet's fur. Looks nice now. This is a silly example, but hopefully it'll get across the difference between abstract classes and interfaces. Okay? So a dog is an animal, and a dog also has fur. A cat is an animal, and a cat also has fur. A turtle and a snake are animals, but they do not have fur, which means they shouldn't have methods that only apply to animals that have fur. And this is the difference between abstract classes and interfaces. If you're a subclass of animal, you have to have all the methods that an animal has. And you can't be a method of two classes at once. If you're an object that is a member of some class or a member of some subclass, you can't be a member of two different classes or two different subclasses. You can, however, implement multiple interfaces as a class. So I can have this interface called has fur and this interface called animal. And I can create a cat that implements animal and has fur. A class can implement multiple interfaces, and that's what makes interfaces different from classes and subclasses. You can only be in one class, but you can implement a bunch of different interfaces. And each of those interfaces is a blueprint for just those methods that apply to you, that make sense to whatever kind of object you are. So, cat implements animal and has fur, and dog implements animal and has fur, but snake only implements animal. So I can now, when I create my, what is that get brushed method is just a default method that belongs to the interface. So it'll be the same whether I call it for a cat or a dog. So if I go down here and say after Hazel makes, let's take the snake out for now. After Hazel makes sound, Hazel get brushed. Brushed. Okay, so dog makes a sound. Hazel's a dog object. It makes a sound. That method is unique to the dog class. And then it can also get brushed. And when it gets brushed, its fur looks nice. And that is a generic method. That's a default method that belongs to the interface. I'm pretty sure in old versions of Java, like before version 8, interfaces couldn't have default methods. They should just they could just have void, empty methods with no body that just serve as a blueprint. In recent versions of Java, you can have a default method like this that belongs only to the interface. So you can maybe start to imagine now how you can have different interfaces that apply only to certain classes. And when you create a class, you can choose which interfaces to implement. I can have an interface called has feet. Oh, what did I just do? Did I type over something? Yeah, has feet. And then a method called run. Your pet is running. Look at them go. Okay. And then the cat and the dog would also implement has feet. Copy. Paste. Okay. And so by implementing that interface, cats and dogs can execute this run method, but snakes can't because snakes don't run, they slither. I could have an interface called, I'm trying to think of something that's just for snakes, an interface called is cold-blooded. I guess I'm using capitals. Is cold-blooded. And a method called warming rock. When you've got a reptile tank, when you got a snake or something, or a iguana in a tank, you put a warming rock, a little heated, electric heated rock on there that they can lie on when it's chilly in your house and get warmed up. So I'll have a method called warming rock, and I can say your pet is warming themselves. Okay. And now I can have the snake implement animal n is cold-blooded. And so I can imagine having categories of behaviors, not categories of types of objects, but categories of behaviors that are unique to particular classes. And a class, when you create a class, you can choose which of those categories of behaviors will be implemented by that class. This is still an example of abstraction because has fur and has feet and is cold-blooded are just blueprints for things. They are not things themselves. They're not objects you can create. They're not they're nothing you can create an instance of in your program. They are collections that you can apply to objects and have them, quote unquote, implement. So the word implement does make sense in this context. It's the word interface that doesn't really make sense to me in this context. Let's put our snake back. Let's create Sid the snake and have him. Oh, Sid is still there. I just haven't had him do anything yet. Let's have Sid dot. I forgot what I called the method now. Where's the is cold-blooded warming rock? That's what I called it. That's not a good name for a method, by the way. Method should be verbs. Warming rock is a noun. I'd have to think harder about what to call that. Maybe just get warm or warm self. warm self is better. Okay, so the snake is able to warm itself. It's a reptile. It has a warming rock in its cage. I couldn't do that with the dog, right? If I have the dog try to warm itself on a rock, it doesn't work. What will it say? What error will I get? Location, variable of Hazel type dog, cannot find symbol. So it doesn't even know what this method means when you attach it to a dog. Why? Because a dog doesn't implement that method. It's not connected to that kind of object at all. The same thing would happen if I tried to brush a snake. If I printed sid.getBrushed, is that what I called it? Did I capitalize the B? No, get brush. If I try to brush my snake, I'll get an error. Right? Cannot find symbol get brushed. Notice it doesn't even recognize the name of the method in the context of trying to apply it to a class that doesn't implement that collection of methods. Okay? That's all there is to interfaces. Again, you might not organically come across the situation where you want to use these anytime in the near future, especially if you're not heading down the track of being somebody who programs in Java for a living. But it is a good example of abstraction. It is a good example of how in object-oriented programming, we want to make it possible to have these categories of object, classes, subclasses, abstract classes, and categories of behaviors, like interfaces. And there are other examples of abstraction that we probably won't get to this semester, that make the organizational part of object-oriented programming, that foreground that organizational part over the kind of variables and functions part that's foregrounded in non-object-oriented programming. Okay, so I'll go ahead and leave it at that.